Okay, let's look at a special type of equation when there are multiple variables in one equation. How do we deal with that? I'll start with the easiest example here. For example, okay, I have one equation, x plus y equals a. Okay, how many variables are there? I see x, I see y, I see the letter A. So depending on what the problem is asking for, in other words, which one is the unknown, I will decide what do I do with it. For example, if I'm asked, solve for x, then I know x is the variable, is the unknown I'm looking for. So I want to get x alone on the left side. And then everything else, no matter their numbers, their letters, there are one letter, two letters, three letters, I really don't mind. I just move all of them to the other side. So I have y here, y should be moved to the right. So a stays, and when we move y, it turns into minus y or negative y. Okay, so that's so for x. If we are asked so for y, same thing here. Now y should stay on the left side and everything else go to the right side. I get a minus x. So this quick review. In chapter 7, when we see the rational equation, okay, and sometimes we see a problem. There are multiple variables there as well. How do we deal with that? Same thing. So here comes one problem. J plus 3 over 6 minus k, okay, equals 8 over 9. This is a rational equation. And there are two variables here. We have to read the problem carefully. So what are we solving for? And I will do both. So for example, if I asked solve for J, this is what I'm going to do. So for any rational equation, if I have the format of one ratio equals another ratio, so the best way to do with that is what? Is to do the cross multiplication. And the cross product should be the same. And then I have 9 times j minus 3 plus 3 equals 8 times 6 minus k. Cross product be the same. And then the same thing as we did in algebra 1 now. I will remove the parentheses using the distributive law. 9j plus 27 equals 6 times 8, 48 minus 8k. All right, so where is unknown? J is unknown. So eventually I want j stays on the left by itself, but I will start with the entire term has the j here. So 9j stays on the left. This 27 should move to the right. So I got 48 minus 8k minus 27. Or you see I minus 27 on both sides, same thing. 40, then, okay, so work this out. I get 9j equals what? So 48 minus 27, that's 21 minus 8k. So what is 8k? We don't care. 8k is just some number. Okay. And how can we get j? I have to divide by 9. So j equals 21 minus 8k, the entire right side, then divide by 9. Final answer. When we have this rational expression here, we have to double check, are we able to simplify it? And for this one, we cannot. So we'll leave it like this. Final answer. If the problem asks for the k, Same thing. So still, I will do the cross multiplication here. Then I will have the cross product the same. I will drag this one here. Same thing. I have 9j plus 27 equals 48 minus 8k. If k is unknown, what I want k stays on one side by itself. So it's up to you. I prefer, okay, I always let the unknown stays on the left. So I will, okay, because 8k is on the right, I'm going to move it to the right. And everything else, they're going to move to the right. So negative 8k move to the left, it turns into positive 8k equals 48 stays on the same side, nothing changes. 9j should be moved to the right, turns into minus 9j. 27 moves to the right, turns to negative 27. See, I have 8k equals combine like terms, 48 minus 27, that is 21 minus 9j here. Are we down? Not yet. I have to solve for k. So k equals what? Divided by its coefficient. The whole right side, 21 minus 9j over 8. Final answer. So always double check your final answer. If we get a rational expression here, are we able to simplify it or not? If yes, then we'll simplify it. All right, so this is the quick example of how to deal with multiple variables in one equation. What's the key? We'll look at which variable is the unknown. If we know that, eventually we'll leave that variable on the left side by itself. Treat every other variable, every other letter, just as number. Move them, divide them, use the addition principle or the multiplication principle as we learned in Algebra 1. Okay, so I hope this helps.